Hello everyone and welcome to St. Andrew's Institute of Technology and Management, Gurgaon, Delhi NCR. St. Andrew's Institute of Technology and Management is the best college in the country. It provides very good quality education. It has a very beautifully developed infrastructure and state of art facilities. This is one of the fastest growing college of the country. It provides 100% job assessment and placement to students. There are a number of um, training programs and modules that are being run for the betterment of the students. The main focus of the college is in providing the best quality education, the best quality development, the best kind of environment to the student. It is one of the finest college, and this is one of the most beautiful choice that you will be making into your career by choosing this college. The subject we shall be looking here in this video is Principles of Software Engineering. The code is CSE 302F. This is a CSE 6 semester subject and the syllabus is in accordance to MDU University Rohtak. We shall be discussing various topics from unit number 4 and it is lecture number from in continuation to the previous 3 lectures. The topics discussed in here are statistical software quality assurance, software reliability, measures of reliability and availability, the ISO 9000 quality standards, 9001 standard, and software configuration management. Now all these standards and the SQA are all very theoretical, and all these 9000 and terms you would have to mug it up, right? So we start the topic. First we come to statistical software quality assurance. For software, statistical quality assurance implies the following steps. Step number 1: information about software defects is collected and categorized, right? So whatever the defects that are occurring in the system, you collect them at a place and then you keep on categorizing it. 2: an attempt is made to trace each defect to its underlying cause. So you try to, after identifying the defect, you try to find out the cause. Example: non-conformations to specification, design error, violation of standards, poor communication with the customer, right? So these are some of the few causes that may be responsible for the errors that are occurring into your system. Third is using the Pareto principle. And what does the Pareto principle says? That 80% of the defects, they are traced to 20% of the causes, right? So it means if you just if you put on try to correct 20% of the causes, then 80% of the defects will get corrected automatically, and you isolate the 20%, that is the vital few, right? So 80%, so out of the total I take it is 100 all the defects, so the first 80 will be occurring from the very 20 kind of cause, and the other 20 are there, they are actually which are not which are different from these 20 causes, will be the one that are different and vital to you, right? Once the vital few causes have been identified, move to correct problem that have caused the defect, right? So only these 20 are the ones that will be actually taking your time, so the rest 80% of the defects that were there, it will be solved very quickly. Next is software reliability and availability. See, reliability, maintainability, and availability, that is you call RAM in software engineering. So there are 3 system attributes, and there's our great interest to both engineers and users, right? Collectively, they affect both the utility and the life cycle cost of a product or system. So what they do, if they are affecting both the life cycle cost also and the utility also of the system. Reliability. What is reliability? Defined as the probability of a system or system element performing its intended function under stated conditions without failure for a given period of time. What do you mean by reliability? This is probability of a system or the system element that is performing its intended function. What is it? Probability of system as well as the element that is performing the intended function under stated condition. under whatever condition that you are providing, it is performing desired results without failure for a given period of time. So without failing, you are performing for a given period of time. A precise definition must include a detailed description of the function. So will this precise description have? This will include a detailed description of the function that is there, the environment that is there, the time scale that is there, and what constitutes a failure. What will this definition include? It will have a detailed description of the function, the environment, the time scale, and what are the reasons of a failure. Each can be surprisingly difficult to define as precisely as one might wish, right? Next we come to maintainability, defined as the probability that a system or system element can be repaired in a defined environment within a specified period of time. Now how do you say it? So you say that this is the amount of time that this will be actually repaired in. So the increased maintainability implies shorter repair time. So if you have an increased maintainability, then it means that all the defects or all the kind of repairment work will be done very quickly, right? Next we come to availability. Okay, defined as the probability that a repairable system or system element is operational at a given point of time under a given set of environmental condition, right? So in that particular rotation and that particular time, so is this system or is this element operational, right? This availability will depend on reliability and maintainability. Okay, so there are very standards that ensure this all these soft reliability, maintainability, and availability. And what are they? We have various quality standards, that is ISO 9000 and ISO 9001 also we have in the later stages, and there is customer like software configuration management that do it. So we look at all these things one by one, right? What the first we'll be discussing that how do we actually ensure these three, the reliability, maintainability, availability, by following this set of standards. So this international standard organization 9000, they had the quality standards that ensures the quality assurance of the system, right? And what do they say? So ISO 9000 is a set of standards for quality assurance system. The standard were developed by the International Organization of Standardization. They were first published in the year 1987. The standard were revised in 1994. They provide a foundation for organization to develop or improve their quality assurance system. So what do? They develop and improve their quality assurance system, right? This is what they do. The ISO 9000 quality assurance model treat an enterprise as a network of interconnected processes. For a quality system to be ISO compliant, these processes must address the areas identified in the standard and must be documented and practiced as described. So what do the ISO 9000 standard implies? They treat an enterprise as a network of interconnected processes, right? So all these enterprises and all these models will be treated as one interconnecting entity, and they have to be ISO compliant, right? And they must address the areas that you identify in the standard, and you must document and practice as it is written into the system. The documenting a process helps an organization understand, control, and improve it. So when you will document it, you will better understand it, control, and improve the process, right? Perhaps the greatest benefit to organization that design and implement ISO compliant quality system. ISO 9000 describe the element of a quality assurance system in general terms. These elements include the organizational structure, procedure, processes, and resources. So what will they have? They will have a structure, they'll have procedures, they'll have processes, and they'll have resources that are needed to implement quality planning, quality control, quality assurance, quality improvement. So all these will ensure your quality in all the phases that you follow. However, ISO 9000 does not describe how an organization should implement these quality system elements. So, what is described, how is not described, right? And consequently, these challenge lie in designing and implementing a quality assurance system that meets the standard and fits the company's product, services, and culture. So, the how is left to the company. So, it will tell you what it wants and how it has to, but how it has to be done is left to you, right? So there are these various quality management principles: the customer focus, leadership, engagement of people, process approach, improvement, evidence-based decision making, relationship management. All these quality management principles you are supposed to follow. So we have ISO 9000. This is a quality management system, fundamental and vocabulary, and this is the one that is referenced in all ISO 9000 standards. Then this 9001 standard, that is quality management system requirements, contain the requirement an organization must comply with to become ISO 9000 standard. So it's higher to it. So what are the requirement that is needed of an organization to become 9001 certified? 9002 are the guidelines for application of 9001 2015. ISO 9004 managing for the sustained success of organization, right? So 9002 is the guideline, 9004 is for continuing the success or managing the success, sustaining it, and you continuously evaluate, or you have to a thorough evaluation and performance improvement that is done throughout, right? And ISO 9001 2015 is the current version of ISO 9001 standard. ISO 9001 lists requirements, while the other standard in the 9000 family provide guidelines and information. People often say ISO 9000 certified, but what they mean is they have met the requirement of the ISO 9000 standard. So they have met it, and that is why they become certified it. Okay. So what is it? So ISO 9015 is a title of a document that outlines the requirement of an organization must maintain in their quality system for ISO 9001 certification. There are several different documents in the ISO 9000 family of standard. 9015 is the only ISO 9 standard that requires certification. So only this is the one that will be requiring certification. ISO 9001 2015 is the most recent standard, and the 2015 references the year of latest revision. Okay, so it was previously called ISO 9001 2008, which became obsolete on September 2018, right? So you keep on like upgrading it and bringing new versions to it, right? So this is the last part. The year specifies the year in which it came. ISO 9001 2015 does not define the actual quality of the product or service. ISO 9000 certification helps you achieve consistent results and continually improves the process. Thus, if you can make a good product most of the time, this helps you make it all of the time. It's just good business practice, right? So this was just that whatever that you have to mug it up. Now we come to software configuration management, right? So software configuration management is a process of systematic. See, we cannot do anything about the standards because they are the standards, and you have to do it, right? You need to understand the process. These are the ones that you need to lay actually your you should lay your brain onto for understanding. So software configuration management is a process to systematically manage, organize, and control the changes in the documents, codes, and other entities during the software development lifecycle. It is abbreviated as the SCM process in software engineering. The primary goal is to increase productivity with minimal mistakes. So you increase your productivity and you make minimum mistakes into it. What are the primary reasons for implementing SCM management system? There are multiple people working on software which is continually updating, right? It may be a case where multiple version, branches, and authors are involved in the project, and team is geographically distributed and works concurrently. So changes in user requirement, policy, budget, schedule need to be accommodated. So as and where from it comes, you need to integrate all of them. Okay, the software should able to run on various machines and OSs. Why? If it is distributed, it has to be platform independent and compatible. Next is helps to develop coordination among stakeholders, which is very necessary. The SCM process is also beneficial to control the cost involved in making changes to a system. So this will also control the cost, right? So any change in the software configuration item will affect the final product, which is very true. See, anything you change in the item ultimately affects your product. So any changes to configuration need to be controlled and managed. See, if I look in this figure, requirement change or any change in team or any change in government policy and introduced, what will it affect? It will affect your code, your project plan, other document, test, and data. So all these will be affected. What are the tasks in SCM process? You do configuration identification, you do baselines, you identify your baselines wherein you work from, you change the control, okay, and then configuration status accounting you do, and configuration audits and reviews. So these are the 5 tasks that actually happens in the SCM process. Okay, so the important question then can be asked out. A short note on statistical software quality assurance. We already discussed SQA, I think, in our first unit or second unit, first lecture or second lecture. I have discussed in both of them, so it is something you can link to back lectures also from unit 4. And that you have software reliability, and what is ISO 9000 quality standards, what is the 9001 standard, and what do you mean by software configuration management. So that is all in today's lecture. Please take care of yourself. Thank you.